How's everyone doing today? How you doing, everybody? Hi, everybody. Project 2 code should be in by now. How many of you all wish you had started earlier? Just a few of you. Did I warn you? Yes? Do I feel bad that you didn't start early? I do not. So, the next assignment is already posted. It is the Project 2 code review. What we're going to do is we're going to take a look at each other's code and review it for each other. So if you go on through Facebook, by which I mean, yeah, if you go look on Blackboard, the assignment's there. We're trying to build our own code review tool because the Blackboard one stinks. However, it's turning out to be a lot more work to build one that I like than I was hoping. So we're going to use the Blackboard one right now. You will be given 4 other people's assignments. You will run them, test them, make sure they work, provide feedback. This for you is an opportunity to see how other people did solve the same problem. You might learn from something from it, you might not. So in the future, I'm trying to have it so that instead of just seeing 4 people's assignments, you're able to browse easily through everyone, and you can see all the code from everyone. So you can get a big range of how people approached it, okay? It is due in 1 week. Questions about that? Yes, Emily? Yes, you will. And it's easy to do well on this. Just do your 4 reviews and put some comments in and you'll get a good grade. I mean, it's pretty, you either do it or you don't, right? And it's not worth a whole bunch of your grade, but it's just helpful for you and helpful for other people. So, yes, sir. Yep. 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 You can test it and see how well it's working. Yes? Sure. If you remind me, email me, I'll put up some test files. I have to create some for the TAs to grade them anyway, so I might as well give them to you all, right? Yes, sir. Uh-huh. I don't know, you might look at it and find that, I don't know, there is a wide range of things people do. It may be that you look at it and you go, hey, this is fine. I don't really have any constructive comments for you. You might look at it and be like, oh, I see that you, I think if I can think of something weird that people did, created like 50 different variables and you only used them once and you copied them around and didn't really need them. So it gets better as the code gets more complex. How's that? This is kind of just, we didn't do it for Project 1 because Project 1's a little bit too easy. And later on, as it goes on, you'll see a wider variety of things. Okay. Other questions? Yes? How's everyone feeling today? It's very wet and rainy today. It's a great day to not be in the Army. I would just tell you that. All right, so last time we talked about a bunch of stuff. I don't remember what, but I remember at the end we were talking about loops. Do y'all remember talking about loops? What are some components of a loop that every loop has? Yes, sir. And a loop might have an initial condition. A for loop has one explicitly. What else? Yes? A Boolean expression that determines whether or not we do the body of the loop again. And I just gave away my last answer, which is? Yes? The body of the loop, which is the stuff that goes inside the loop. What kind of things can you have inside the body of the loop? Can you have if statements? Can you have switch statements? Can you do math computations? Can you have other loops? What can you not have inside the body of the loop that we've learned about? You might or may not be able to declare a variable inside a loop. If you try, the compiler may or may not complain, but I think it works. I haven't done it recently. Anything else? You should be able to have everything we've learned inside the body of the loop. Okay? Absolutely everything. In fact, as we go through this course, the question I always get is, hey, can you have this inside this? And the answer is always yes. Almost always yes. The first loop we learned about was the while loop. When do you use a while loop? Yes, sir. When you don't know if it's going to have to run or not, and if you don't know, yep. Yeah, how many times it'll run, right? If you know you're going to loop for a while, hence the name while loop, you use the while loop. A do while loop, when do you use this? Yes, sir. when you want to make sure that the body of the loop executes at least one time, regardless of whether the Boolean condition is met or not, right? With a while loop, there is no guarantee that you're going to go and execute the body of the loop, but with a do while loop, you are guaranteed to execute it at least once. In this case, the Boolean expression, the conditional, is at the bottom after the body. And finally, we have a for loop. When do we use the for loop most often? Yes, sir. Yes, when you know pretty much exactly how many times you want the loop to do something, generally you use a for loop then. And there's a fourth type of loop, which is still a mystery. Okay. So let's say we wanted to count all numbers from 0 to minus 1,000. What type of loop would we use? A what? A for loop. But we're going down, right? Does that matter? It doesn't, right? So before I called the thing, before I called the portion of the loop that we were going to use, the incrementer, you can increment with negative. So here's a little program. Let's output all the numbers from 0 to minus 1,000. What loop are we using? For loop. What are the three components that go inside the parentheses of a for loop? The first one's an initial condition. What will our initial condition be here? Okay, so we're going to have an integer. We need to give it a name. Very frequently, inside loops, we'll just use a very short variable name if it doesn't have any meaning. For this, we might choose something like count. Then what do we have? Semicolon, and then the Boolean condition. And what is our condition in this case? While what? X is greater than or equal to negative 1,000. All right, where are you getting X from, though? Mm-hmm. Yeah. Didn't I tell you all I was always going to get these wrong? Does that make sense? And what are we going to do here at the end? Our last portion here is what? The decrement or incrementer. We just increment negative. How do we do that? All right, we have a variety of things. I'm just going to do count minus minus, right? We could do minus equals 1, whatever we wanted. And then here we just want to output count. And let's go compile it and see if that works or not. So I called this program for-1000.cc.outpass4-1000. Be bigger, please. Really? All right. Clear that. It compiled correctly, right? /4-1000. And I'm going to do this, which allows us to look at it a page at a time. Does that look like it's working? Is it going to stop at the end? Yes, it is. And of course, we're missing the edge of the screen, as we always are. How's that? Good? Okay. So that's a for loop, an example of a for loop. How about a different type loop? How about if we want to show a human a menu of choices and allow the human to make a choice repeatedly? Which loop do we use for that? We have a while loop. What else? A while loop or do while loop. How about a for loop? Do we know how many times the person's going to type something? We don't, because humans range from imperfect to suck, and so we don't know what humans are going to do, right? So we have our choice of a while loop or a do while loop. Which one do you think is appropriate here? Why a do while? Because we want to give the human a chance to use the menu at least one time, right? At least one time. So it would be appropriate to use a do while loop here. So let's write a little do while loop. So here's a little program. We can say do while. Okay. So we can have something, a character, like the choice, and we'll set it equal to something we know what it is initially, right? And we can do something like give them a display. Your choices are A, B, C, D, F, or Q to quit. Right. And we'll tell them what their choice was. And we'll keep doing this while choice is not equal to Q. In fact, let's make that a little bit better so we get uppercase 2 just because, you know, can you predict whether people are going to use uppercase or lowercase? Most of the time you cannot. I know some people who only type in lowercase, so with them, if I knew they were the only ones using the program, I could do that, and we're done. All right, so does this look reasonable to everybody? Anybody spot something that's going to keep it from compiling? No? I don't know if there's there or not. I was just asking. Yep, so here's our do. These brackets contain the body. So this is the body. Then we have the while and choice. Oh, we're missing a semicolon at the end of this. And our Boolean condition is as long as the person hasn't chosen Q, they will keep getting the same option over again. Yes, sir? While choice is not equal to Q. Yes. Yep. Yep. You're right. Here, actually, you know what? I have a Three Musketeers. Sorry. I thought I had some candy. That was an empty wrapper. I must have eaten it. You ready? All right. So let's see if this works. It compiled cleanly. All right, your choice are A, B, C, D, F, or Q to quit. Which one do you want? Z. Your choice was Z. We don't have any logic in there to tell you to check if it got the right choice or not, because we're just showing how the loop works. Any other choices? A. Any other choices? There you go. Does that make sense to everybody? Let me put the code back up. Our next project that we do is going to have a portion where you're going to be giving people choices from a menu. Anybody see any relevance to what I just did here, to what might happen in the future? No? All right. Well, this is an example. You'll have to fill it out in your program. Typically, you use like a switch statement to figure out which choice people made. Yes? The for code? Yep. Oh, I'll post these on Blackboard, too, when I get back to my office. Yes, sir? Mm-hmm. Yep. Yep. Yes. If you want to make sure that's that the way that we've constructed it here, you don't strictly need a do while loop. I'm just trying to come up with an example that's simple that illustrates a case when you might want to. There are many cases in a do while loop where you're getting some sort of input, and then you reach the loop and you want to do it once anyway, regardless of not whether the input was there. But I tried to come up with something that was a little more relevant to the projects and stuff. Yeah, so you can use a while loop, but all loops are equivalent. We could use a for loop for this, right? They're all kind of the same. You just have to be careful about your initial conditions and such. Everybody good so far? All right, and then we talked about you want to count some lines in a file. What loop would you use for this? A while loop. Do you already know how to do this? Did y'all do this in your project? All right. Great. So that's our fast review of loops. I've been meaning to have some handouts, some in-class exercises. Oh, wait. I want to show you one more thing first. And then we'll talk about it. Okay. Okay. So we're going to do one more thing here. Sometimes there are situations where you're inside a loop and you're running along, and one of two things can happen. Either you might decide that you want to end the loop early, like just get out of the loop because something has gone wrong, or you might decide that the current pass through the loop needs to stop and you need to jump on to the next one. Okay? For example, in this last project, how many of you were looking for ways after you read a bad line of code, like one of the inputs was out of range, how many of you wanted to find a way to jump directly to the next line? Most people? There's an easier way to do that than we showed you before. How many of y'all just used an if statement and like skip some stuff to go to the bottom of the loop? Okay. And sometimes you might want to exit the loop completely, and there are constructs for that. So let's make a loop for int I equals a, I less than or equal to z, I plus plus. Does this look a little weird? What is this going to do? So, oh, sorry, that should be car. It might work too, but we should make that car. Okay. So, what is our initial condition? We have a character. What is its name? What is stored inside of it? The letter lowercase a. We have a Boolean condition, which is I less than or equal to z. Is a less than or equal to z? Probably. Remember we looked back at that magic code page? We're working in this realm of code numbers. I believe I is going to be less than or equal to z. Anybody think I'm wrong? I could be. It's happened before. Okay. And what is I plus plus going to do? It's going to increment what? The character I. So let's see what this does. C out, angle, I. And we'll just run them all together for time being, okay? Everybody good on this? So let's see what this loop does. So it compiled cleanly. And look, it outputted the alphabet. Now, of course, I didn't put an end line at the end, so it put my prompt that says sphere-4 at the end, but we just iterated over the whole alphabet. Is that kind of cool? Let's say, and I'll put an end line in there so that we can break things. Let's say we want to show all the letters of the alphabet. Did we just do that? Are we happy? But there are some letters that we do not like. What letters don't we like? M? I do not like M either. Okay. So, is M bad enough that when you see it you want to just quit, or do you just want to skip it and go to the next letter? Okay. So, because we don't like the letter M, sorry, wrong place there. Because we don't like the letter M, we say if I, which is the variable name, has the letter M in it, we are just going to skip on to the next one, and we do that with the word continue. Yes, it should be. Thank you very much. Okay. Now we have this. We're looping over the letters. We say if I is equal to M, continue. What continue says is, hey, we're not going to wait to get to the end of the loop to go back up to the top. Just go ahead and go right back up to the top. For a for loop, it also includes doing the incrementer as well. Does this make sense? So, what is this going to print out when we run it? The whole alphabet without M is one prediction. Let's see if that's correct or not. A, B, C, D, F, G, H, I, J, K, L, N. There is no M. We skipped over the M. Does that make sense? This is what you could have used in your last program when you had a line that had an error. You could have just put continue, and instead of doing all the processing, it would have jumped back up and processed the next line. Does that make sense? All right, so that is continue, which means go to the next loop iteration. By the way, have I used the word iteration in here, or iterate? This is a fancy computer science word that means go through the loop, right? Each time you go through the loop is one iteration. If you're going through the loop a whole bunch of times, you are iterating through the loop. Pretty exciting word, I can tell. All right, there's some other letters we don't like, which are what? Okay, Q. And we say if I is equal to Q, break. And what I'm going to do now is I'm going to put this out here. I'm going to make a little message, done. Done with loop, so we know we're done with the loop. All right, so here's what we do. We say if I is equal to M, continue. If I is equal to Q, break. And break means terminate the loop. Terminate the loop. Now, I used iterate, which means go to the next iteration. Do you all need to know what terminate means? No. Let's see if this works. A, B, C, D, E, F, G, H, I, J, K, L. Where did M go? We skipped it using what? Continue. N, O, P. We got to Q, and what happened? We didn't like it, and we said if we see Q, we're done. Yes?
So that's the same break within a switch.
Yes. You can think of it the same way. Inside a loop, break means terminate the loop. Inside a switch, break means jump to the bottom of the switch. So yes, it can be the same break. Yes? Why does it terminate where? Because the only time, because what it does is when you hit break, it goes, oh, I'm supposed to exit a loop. Let me look back up and find the loop that I'm inside. And it goes, ah, here's the loop I'm inside. So I will exit that loop. It does not work for if statements. Yeah, it doesn't have anything effect on if statements. Yes? Or what? No. They are somehow related that I'm not going to get into magically. Though I want to because I think it's really cool. It's just not appropriate field. So yeah. Oh, I did this one. I put this one so that we'd end this line, like in the printout up here where I'm doing this one, and then the done with the loop would appear on the next line. So I just did that so it wouldn't be all jammed together. Yes? You cannot use a break for an if statement. Yes, this break is inside the loop. When the compiler runs along, computer, what is a computer? But it's done so it sits here and it goes, okay, I start right here, int main for, oh, I'm going to start, create a variable named A, check if it's less than Z, it is. So I go in here, it says, oh, I look in this box, is A equal to M? It's not. Is A equal to Q? It's not. I print it, I go back up, right? It runs along. Eventually it gets to I equals Q and it goes, okay, I equals Q. Wait a minute. I'm supposed to do something here. And it looks and it goes, break. And I goes, aha, break. What do I do? And it goes, is this a loop? No, is this a loop? It looks backwards and it goes, oh, here's a loop right here. And it breaks out of that loop. Does that make sense? Let me prove this to you. Let's put this for loop inside another loop. Okay, so here's what I did. I just added another loop that says for int x equals 1, x less than 5, x plus plus. How many times will that loop execute? How many times? 4 or 5? 4 or 5? How many of you think 4? How many of you think 5? How many of you have no opinion on the matter? Okay, it should do it 4 times, right? And what's going to happen is we're going to see when this run, we're going to break out of the inside loop, but we should not break out of the outside loop unless something horrible has gone wrong. So it did the inside loop 1, 2, 3, 4 times. Okay, so that break just breaks out of the most recent loop. Got it? Most recent loop. Everybody good? Yes, sir. Yes. But finish your question. You want to break out of both loops? You would have to keep track of whether you broke out of the first loop. So what I would do is I would add a loop variable called broken, and here I would set broken to true, and then when we jumped out of this, I would say if broken true, break out of the next one too. There is no one command that will break out of all loops. Break only applies to one loop at a time. Everybody good? Yes, sir. You can have switch statement inside switch statement, and yes, you need separate breaks for each switch statement. It only breaks out of the most recent switch statement. Other questions? All right, so you don't have to just sit and listen to me talk all day. I have some exercises. Do you remember the first day we did partner-assisted exercises? We're going to do some of those. There are 2 things. On the front, there is something called an odd for loop, and on the back, there is something called break and continue. So your task is to figure out what these things print out. Okay, one person will do the odd for loop first and then break and continue. Does that make sense? It would take about, I don't know, 8, 10 minutes to do this. Find a partner. One person solves, the other person talks. All right. I need 2 brave volunteers. Someone to walk me through the, which one are we doing first? Odd for loop? Who wants to walk me through the odd for loop? Emily, you do? All right. So here's what I'm going to do. I'm going to draw a little table because this is how I actually keep track of these things. And we're going to walk through it and see. So where do we start? I don't know. Which one do you want to do? Okay. We will do the odd one. Mm-hmm. And then what happens? Uh-huh. Yep. Yep. Uh-huh. And is C equal to Y right now? What is it equal to? It's just a space. Then what do we do? Y. At. Mm-hmm. Yep. Okay. So it says we have this string. How many letters are in that string? 7? 5? And they are numbered what? 0 through. So when we say at 0, what letter do we get? And so what happens to the variable named C? Uh-huh. Yep. Uh-huh. Mm-hmm. Yep. All right, so I'm skipping ahead a couple of iterations there, right? All right, so here's one way to think about solving these problems. Here you go. Oh, sorry about that. Okay, here's how I generally recommend you solve these problems, right? Create a little table for each variable that you're going to have, write what's in there, and then just go step by step through the algorithm. When you go back to the top of the loop, just create a brand new line, okay? You can keep track in a little table of what's going on inside whatever little problem I give you, and it becomes relatively easy to solve these problems, as long as you know what the different keywords mean, right? Computers are, but they're dumb. You are smart, but you're smart, very slow, okay? So if the computer, which is dumb, can do this, you are smart, you can also do this. You just have to keep careful track of what's going on, all right? That's all the computer is doing. It's relatively straightforward. So create a little table, just keep track of which variable is which, and step on through the code line by line. Here's what's going to happen. I'll just warn you, you're going to get bored because the computer is doing such dumb things. It has infinite patience because it's dumb, and you're going to be tempted to skip ahead and be like, I see where this is going. And you just skip ahead, and that's where you'll make mistakes. Okay. But for the midterm, when is the midterm? It's in 2 weeks, isn't it? Man, you scared me. I was like, I have to write a midterm already? Anyway, but for the midterm, the questions that you get will be similar to this, right? And you would just have to demonstrate your knowledge of how the C++ language works by demonstrating that you can step through. I might also ask you to do something like we did at the beginning of the class, which is create a loop that does, prints out all numbers from 100 to 250 in steps of 15, right? And you would have to say, what kind of loop is that? Why? How do you step by 15? Where do you start? 200? Does that seem pretty easy? It's pretty straightforward, okay? It's pretty straightforward. So, computers are dumb, very, very fast. You are smart. Unfortunately, you're a little slower than a computer. And we have to feed you more, sadly. But. Okay, so everybody see how we did that? Does this make sense? Who wants to do the next one? Yes?
So the next one.
Wait, let me find the eraser. And okay, go ahead. Okay, so we have a variable m, we have a variable n, and what m, okay?
Yeah, so we input 4 for m.
Uh-huh.
2 for n.
Uh-huh.
Okay, and then there's a for loop.
Mm-hmm.
So the for loop, it sets up another variable, L.
Yep.
And the loop's going to run for L equals 0, 1, 2, 3, 4, or no, it's not. It's not going to run for all of this.
You would expect, no, you're doing the right thing. You look at this loop, and without looking at the body, you say, oh, we start at 0, we go to 6. Each time we step by 1, right? We go less than 6. So what do you expect to see? 0, 1, 2, 3, 4, 5. You should be able to look at loops like a for loop and predict, based on what's in there, what you expect to see come out. Okay? Because what do we know about for loops? We use them when when we know, right? So if you look at for loops, you should be able to look at a for loop and go, oh, here's where we start, here's where we finish, here's how we step in between. Okay, does that make sense? Okay.
Okay. So, and what the loop's gonna do is it's gonna increment L
Uh-huh.
by 1, and it's gonna output that value.
Okay.
So,
So the first, so we're right, let's just say we're right here at the loop. We've just set up the loop conditions, right?
so
4, 2, 0. Yep.
So we go into the loop,
Uh-huh.
and it says L if L equals n,
Is L equal to n?
and it's not.
Okay.
So
What's in this box?
0.
What's in this box? Is 0 equal to 2? Anybody disagree? It makes my grading easier if you think other numbers are equal to 0. All right.
So
Uh-huh.
that's not true.
Yep.
So you keep going in the loop,
Uh-huh.
and so you output L.
Nope. We have to make one more check, don't we?
Oh, right. Sorry. So then it checks if L equal to m.
And it's
So 0 is not equal to 4.
Mhm.
So we continue in the loop, and then we get to output L, which is 0, and then increment L. So now
Mhm.
output 1.
Yep.
So we go back to the top, check does L equal n? 1 does not equal 2.
Yep.
Keep going.
1 is not equal to 2, 1 is not equal to 4. These things stay the same, they're unchanged, right?
Output 1.
Yep.
Okay, now, and then you add, now it's L is equal to 2.
Yep.
So you go back up and you check, well, now L equals n.
Is 2 equal to 2?
Equal to 2.
How many of y'all think 2 is equal to 2? So what do we do?
So now you continue. So
Uh-huh.
you just skip
Yep.
that and go back to the top. And now
Yep.
L is equal to 3,
Mm-hmm.
which is not equal to n, and it's also not equal to m. So you go output 3.
Yep.
Go back to the top. Now it's equal to 4. Doesn't equal n, but it does equal m. So
Uh-huh.
now you just stop.
Yep. Everybody see how that works? Great. Everybody kind of see how you can trace this code through? Yes? Because we hit break. I'm sorry, this is the wrong code. Because we hit break, and break means to stop the loop. For a for loop, it stops the loop without ever running the incrementer. Okay? For a for loop, it stops the loop without ever running the incrementer. Everybody makes sense? That makes sense to everybody? Yes? Oh, it says 0, 1, 3. And I put a line there because I wasn't thinking. But all right. Thank you very much. Okay. Okay. Everybody think they're kind of good on loops? We'll find out. But if you follow this procedure, if you just do what the dumb computer does and are very thorough step by step, and just go step by step, you should be able to do it. Okay? Everybody good? All right. We are going to learn something new now. And in fact, in some sense, it is the very last new thing we will learn all semester, by some measure of new. Do you remember the second day of class? How many of you remember that? One of the things we talked about, and what did we talk about the second day of class? Do you remember? Algorithms. What is an algorithm? An algorithm is a series of ordered steps that accomplishes some task, and a program is an expression of an algorithm that a human can read and a computer can execute. Okay? I think we went over that maybe like quickly once. So, all right. So when we talked about flowcharting, we talked about just a few things, right? We talked about this. What is this? Start or stop. And have we seen start or stop? Yeah, we have. We talked about this. What was this? Some arbitrary computation. We talked about parallelograms. What were these? Input and output. We talked about decisions, right? And where have we seen decisions? We've seen them in 2 or 3 places. If statements. Where else? switch statements, and loops, right? All loops have this Boolean expression. There's only one other thing we talked about in terms of flowcharting that we haven't done yet. Anybody remember what that is? I think I drew it kind of like that before. Pardon? No, not yet. Okay, yes, so what we talked about was like what I called a sub-algorithm at the time, right? Where we could take a series of steps and package them up into a single step that could be reused over and over again. And that was the very basic way I've done it, but that's what we talked about. It turns out we have been using these functions already, haven't we? What have we used functions for? Math? Yeah, we've used math functions, right? Power, log, stuff like that. We have also used them in another form, also called methods, right? You remember talking about methods? Name a variable type that has a method. Name another variable type besides string that has a method. ifstream and ofstream. Anything that has a dot after it is a method is really a sub-algorithm that does some function, right? Methods and functions are just ways of having sub-algorithms that do some function. Now, you can think of it like this. When people designed the C++ language, they came up with a certain number of words that you could use to do things in the language, right? And the set that they came up with was relatively limited. Why is it limited? Because computers are dumb and they came up with things that the computers could do by themselves. If we want to do something smart, we have to put our own algorithm together out of these dumb things. But what's nice is after we've constructed an algorithm, to be able to reuse it again and again without having to type the whole damn thing out, right? Or put 100 lines or 400 lines of code in there. Let's say, for example, in the last project, we calculated the Reynolds risk score, didn't we? For each line out of the file. And so we used that hundreds of times. What if for project 2 we had wanted to do the Framingham risk score again? How long was that? Was it pretty long? Was it annoyingly long? Yeah, good. Would it be easier for us to type the Framingham code over and over again in there? Or would it be easier for us just to package the Framingham code up into one thing where you could just say Framingham equals Framingham, X equals Framingham something? How many of y'all would like to type it over and over again? You have a great career ahead of you in data entry until you're replaced by a scanner and OCR, which was probably like 10 years ago now that I think about it. But everybody else, right, it's way better for us to just package things up. So that's what we're going to start working on. We are going to learn how to create our own little sub-algorithms, which we can then use as if it were just part of the language. All right? Everybody excited by this? This is you know how I told you the class is pretty easy and starts ramping up? The class is easy and starts ramping up, but the things that you're learning as it's ramping up become more and more powerful. This is your first step into very powerful things, okay? We're wading out of the kiddie pool into the not deep end of the other pool, so, which is really a horrible analogy. All right, so let me show you how we do this. Well, when we want to create a function, there is a very specific format we use for that. And I will, let me just save this. Sorry. All right, there's a very specific format. First of all, let's just figure out what function we're gonna create. And I would like to create something pretty easy. How about this? We're going to create a pretty simple function where we are able to print out a line across the screen to break up our output. Okay? So I might originally have done something like this. Hello. And then I could say, you know, cout, angle, angle, quote. Hello, how are you? With lines in between them. Okay. It gets annoying to put all these little dashes in every single time. And again, I'm starting with a simple function. We'll work up to more complicated ones as we go on. Okay. So let's see if that works. How is that? Hello, how are you? So you've created this hello, how are you program for a very important client, and they look at it and they go, oh yeah, it does just what I want, but can we change the dash lines around a little bit? Because I'm not sure that 10 or 12 is the right number. I'd rather have 16. Okay. So how do you change this? You have to go into the program and you have to like go, oh yeah, 16, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I have to add 2, and then you go over here and you add 2. And if you had more of these, you'd have to hunt through them. And that would be annoying, right? Okay, so here's what we're going to do. Instead of trying to print out and make this a static string, we are going to write a function that will print out the number of dashes that we're supposed to have. Everybody good with that? All right, when you write a function, there are a couple of things that has to happen. And I will put them up here. All right. The first thing we have to do when we write a function is before the int main, declare something called the function prototype. The function prototype. What the function prototype is, it's a warning for the compiler when it compiles your program of what it can expect to see. All right? Each function in a function prototype has 3 things. A return type, a name, a parenthesis, and what are called the parameters, which is really, I'll just call it the parameter list. So a function prototype has a return type, a name, and then a parameter list. The parameter list is the input that the function needs in order to run correctly. Okay? The function list, the parameter list is the input that the function needs in order to run correctly. And we've seen this before, right? When you call a math function, you have parentheses and you put some stuff inside. Yes? Put variables inside. So we're going to do exactly the same thing. For a function prototype, we're going to have what's called the formal parameter list. And then later, for the function, we're going to have what's called an actual parameter list. So the return type is one of the types that we have already seen. What types can variables have? Int, what else? Character, float, double char. Keep going. String, bool. Any of these things, pardon? We'll get to that. Any of these things can be parameters. This essentially tells you, when you evaluate the function, what it's going to turn out to be. Okay? So if we're doing like a math function, it would probably be int or float. If we were doing something with strings, the return type might be a string. Do you have a question? I'll show you in a second. Okay, so the return type. The weird thing about functions is that sometimes we don't have anything to pass back, right? Like a function is sometimes you get input and it gives you back output. Does that make sense? We're giving the input through the parameter list, and we're getting output through the return value, as you'll see in a minute. But on occasion, there is nothing to hand back. There is no result of computation. So there is one type that exists that we will use for functions that we will never use for variables, and it is called void. Void is what happens if you're going to return nothing. So let me just make a note here, the return type. Which is everything we have seen plus this thing called void. And void means there's nothing. There is no result of this computation that we need to work off of. And then after we've done void, we'll talk about some others and you'll kind of see how they work. Okay? Everybody with me? The name is just a name. It can be similar to any variable name. And then the parameter list depends on what we're doing. So here's what we're going to do. We are going to declare a function that does not return anything. It does not do any computation that we need to use, so we call it void. And we'll call this print dashes. And what it's going to take is an integer. And this integer is going to be the number of dashes to print out. Everybody with me? Who's with me? Who's against me? All right. Now what we're doing with the function prototype is we put this ahead of int main so that when the compiler is reading through the code, if we put print dashes down here, it doesn't go, I've never heard of print dashes. I don't know what you're talking about. Okay? This up here is the function prototype. It is just a warning to the compiler to expect to see that later. Yes? Then, in order to write the function, we actually go down someplace else. Typically, we put it below main, and we write the same thing, void print dashes int. And this is down here. This is the function declaration. And it's going to have a similar format. It's going to have a return type. It's going to have a name. It's going to have a parenthesis and then an actual parameter list. And then a close parenthesis. So here we have print dashes, and I'm going to call this num dashes. And that is the declaration. Now, I was asked before, I'm going to split the screen in two so we can see the function prototype and the declaration at the same time in different windows here. So there's the function prototype at the head, void print dashes int. Here is the actual declaration, void print dashes int. The difference between the formal parameters and the actual parameters is that the formal parameters just tell what type you're going to expect, and the actual parameters give it a name. Everybody with me? Cool. All right, so we have 2 minutes left, so here's what I'm going to do. I'm going to just rip out what we're going to do with the rest of this function really fast, and then we'll show you that it works, and we'll go. So all print dashes does is for int x equals 0, x less than num dashes, x plus plus. What type of loop is that? And how many times is it going to run? Yep. It will run the number of dashes time. We don't have to have any return because it is void. And now what we can do is we can say one second. And I missed something down here. Oh, yeah, you're right. Thank you.
I also have a question about in the function declaration.
Yeah.
So you have to also specify the wait. So what is int and num dashes? What are those doing?
Okay. This is the parameter that feeds into the function how many things are supposed to happen. And I kind of was iffy of whether I should start or not, but we had so much time left it seemed worthwhile. Here's what's going to happen. When this program runs, we started int main, right? We go step by step. What's the first thing we do? Output hello. The next thing we say print dashes. The compiler goes, oh, I remember up at the top of the program you had a function prototype that warned me to expect something called print dashes. Now that I've seen it, I can go look down here and it says, oh, here's something called print dashes. And look, it's got this int, num dashes. Well, what's that 16 right there? It's an int, and this value gets copied into num dashes. So when it sees this, it goes, okay, I'll take this 16, I'll copy it into there. Now I will start running this argument. It goes, so for int equals 0, okay, x is 0, x less than 16, x plus plus, print out a dash. After I'm done printing out the dashes, I print out an endlel, and when I'm done, I just go back, I jump back up and go to the very next line. Okay. So let me compile this, and I will show you that it works. Please work. That's not very exciting. You can see the line's a little bit longer. How about if we put 160 dashes? That'll be pretty exciting, won't it? All right. All right. Yeah, it looped, it went all the way past the screen and just kept wrapping around. So, all right, one quick question. Yes, sir.
Do you have to declare num dashes in the function?
Yes, num dashes is the actual parameter, and it's defined right there.
What if you were wanting to use that?
You cannot. This num dashes only exists inside the function. It does not exist inside main. And we'll talk more about that next time. Okay? Yes? We do, but yeah. But it's easier to change this than it is stuff. And we'll get moved past that too. Okay?